Solubility of a gas in a liquid. Many gases dissolve in water. Some gases are highly soluble in water like hydrogen chloride gas, and some dissolve to a very small extent in water like oxygen. Solubility of gases in liquid is affected both by pressure and temperature. Usually solubility of gases increase with increase of pressure. Now, in this diagram, there is a solution phase and there is a vapor phase. Now, this is a movable piston and these are the gas particles, some of which have dissolved, and there is an equilibrium existing between particles which are going into solution and some particles are going from the solution into the vapor phase. On increasing the pressure, here weights are added. So on increasing the pressure, the piston moves down and volume available for the gaseous particle above the solution. This is the volume which is available to the gaseous particle above the solution. It decreases. So number of particles per unit volume will increase and number of particles striking the surface of the solution will increase. As a result of which, what will happen? More and more solute particles will go into the solution, or in other words, solubility will increase and a new equilibrium will be reached in which some of the gaseous particles are going into the solution and some gaseous particles are going from the solution into the vapor phase. So a totally new equilibrium will be established. From this we can make out that the solubility of gases increases with increase in pressure. Now a quantitative relation between pressure and solubility of gas in a solvent was given by Henry and it is known as Henry's law. अब ये law क्या state करता है? The law states that at constant temperature, means temperature has to be constant. This is important because temperature also affects the solubility of the gas in a liquid. So if we want to show the effect of pressure on the solubility of a gas in liquid, we have to keep the temperature constant. So at constant temperature, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of the liquid or solution. So solubility is directly proportional to the partial pressure of the gas, which is present above the surface of the liquid. Dalton also concluded independently that the solubility of a gas in a liquid solution is a function of partial pressure of the gas. Now, we can also express solubility as mole fraction of a gas which is present in the solution. So, mole fraction of a gas in solution can be used as a measure of its solubility, and in that case, it can be said that mole fraction of a gas in solution is proportional to the partial pressure of the gas over the solution. And the most commonly used form of Henry's law states that the partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas in the solution, and it is expressed as P is equal to Kh into mole fraction. So partial pressure of the gas in vapor phase is directly proportional to mole fraction of the gas in the solution. So this is the commonly used form of Henry's law, and putting the proportionality constant, P is equal to Kh into X. X denotes the mole fraction of the gas present in the solution and Kh denotes the Henry's constant. Now from this, Kh is equal to P divided by X. So it can be seen that if the pressure is kept constant, in that case, higher the value of Kh, lower is the mole fraction of the gas present in the solution, and the value of Henry's constant is different for different gases at the same temperature. For example, nitrogen has different value of Kh, oxygen has different value of Kh provided the temperature is same. So Kh is a function of the nature of the gas, and Kh is inversely proportional to the mole fraction of the gas present in solution. So higher is the value of Kh, lower is the mole fraction of the gas in the solution, or we can also say if Kh increases, solubility of a gas in a given solvent decreases. Now, value of Kh for nitrogen and oxygen increases with increase of temperature. So With increase in temperature, solubility of nitrogen and oxygen will decrease, and with decrease of temperature, the solubility of nitrogen and oxygen will increase, because when temperature decreases, then in case of nitrogen and oxygen, the value of KH also decreases. So if there is a question that why the aquatic species are more comfortable in cold waters rather than in warm water, this is so because in cold water the temperature is low, as a result of which value of KH for nitrogen and oxygen is low, due to which solubility of nitrogen and oxygen in water at low temperatures is greater than that at high temperatures, which helps the aquatic species to be more comfortable in cold water than in warm water. This is a graph. Y-axis we have partial pressure of HCl, x-axis mole fraction of HCl. Now this graph is a straight line showing that partial pressure of a gas in vapor phase is directly proportional to the mole fraction of the gas in the solution.